So this is the second video in naming, okay? Today we're going to look at the naming rules when we have a polyatomic ion. Polyatomic, there we go. Okay, so the last video we just looked at binary compounds, so that meant two elements, and we looked at both the differences in ionic and covalent compounds and how we name them. So now we're just going to make things a little bit more complicated, and we're going to look at polyatomic ions. So, oops, I just lost my slide. There we are. So, what is a polyatomic ion? I hope that a lot of this is review for you, but if not, then at least you have all the rules here, you can learn them. So, a polyatomic ion is basically formed from more than one atom joined together by covalent bonds. So, polyatomics are usually made up of all non-metals. And the rules for naming are the same as before, but you're going to name the polyatomic as a unit. So nothing's really changing, except the ending of your compound is no longer going to be with IDE. It's instead going to end with a polyatomic. So here's your list of common ions. What I think you should do, and I'm going to toggle back and forth between this slide and the next slide, but I've got this highlighted row right here. And I put at the end here that you have to know this one. This is the one you need to memorize. Okay? And it basically tells you all the polyatomic ions that end in 8. Okay? So PO4 3- is phosphate. NO3 1- is nitrate. SO4 2- is sulfate. So those are the ones that you should memorize. If you do that, the rest of this chart actually becomes really easy. So if you know this one, so if I ask you, okay, what is a carbonate ion, and you know that's CO3 2-, what happens is if you add one more oxygen to your formula, you don't change anything else. So you leave the element that's first, okay, you leave the charge alone and you just add one extra oxygen. What you do is you add a per in front as a prefix, okay? So carbonate, which is CO3 2-, if I change it to CO4 2-, it becomes percarbonate. Now, some more rules. If I take away and I have one less oxygen, so again, everything stays the same, but instead of CO3, I end up with, say, CO2 2-, I change the ending from 8 to ite. So instead of carbonate, I have one less oxygen, therefore I have the carbonite ion. And then again, if I take away 2 less oxygens from that column that I originally started with, so if I start off with CO3 and I end up with CO 2-, I add the prefix hypo in front, so hypoite. So this would be hypocarbonite. So if you can memorize those 8 ions, those gray shaded ions, then the rest of the chart you can figure out just by adding or taking away oxygens. It actually ends up being a lot easier. So now the question is, well, do you have an easy way to remember the 8 ions, the ions that end in 8? And I do. So I have this little rhyme. Nick the Camel had a clam supper in Phoenix. Now, I'm not going to take credit for this. I sure as heck didn't make this one up. But what this does is it tells you the polyatomic ions that end with 8. Okay? And the way it does that is by the number of consonants and vowels in the word. So Nick is the same as nitrate, Camel, Ca, carbonate, Ca, clam, Cl, chlorate, same thing. Supper goes with sulfate, Phoenix goes with phosphate. I've got 2 ions here, 2 polyatomic ions here that don't fit in with Nick the Camel, but hopefully you can remember that they fit in with chlorate and the rest of it gets easier. So here's how it works. The number of consonants in the word tells you how many oxygens are present. The number of vowels in the word tells you the charge. So for example, if I look at the word Nick, this will tell me the nitrate ion, what the nitrate ion looks like. So I've got 3 consonants. I know I have a nitrogen. I have to have oxygen in there. So 1, 2, 3 consonants says I've got NO3. And then the number of vowels, I only have one vowel, the letter I, and that tells me the charge. So I have a 1- charge because I only have one vowel in the word. So the word Nick basically helped me figure out that the nitrate formula is NO3 1 minus. And if I look back on my previous slide, look, nitrate NO3 1 minus, done. So this works for all of those words, and it's an easier way to help you memorize those 8 ions, okay? So if I go back here, I'm going to write the word Nick here. So Nick, if you memorize Nick the Camel had a clam supper in Phoenix, that'll help you memorize the gray shaded areas. And then if you start taking away your oxygens or adding an extra oxygen, that's how you figure out all the other type of ions. Another way you can do this is actually make flashcards and quiz yourself on it, which we'll probably do a little bit in class. But anyways, those are some tools for you to learn your polyatomic ions, because you will not be given them on a quiz or a test. So let's practice some. Here are some compounds with polyatomic ions. I'll give you a second if you want to pause to practice these, and then we'll take up some of the answers. All right, so sodium chlorate, again, it ends, so this is different. So I want you to look at the difference between sodium chlorate and sodium chloride. So chloride, if it ends in IDE, that means it's binary, which means it's just sodium and chlorine bonded together. NaCl, you check your charges and you crisscross and you're done. The second you see an ending with 8, then we've got something different. We've got a polyatomic that we have to deal with. So, come on, erase for me. So we have to remember our Nick the Camel rhyme, or just have them all memorized. So for sodium chlorate, sodium is Na1 plus, and I can figure out that chlorate is ClO3 1 minus. So again, I have them memorized. I use them quite often. You need to have them memorized as well. So if we crisscross these, I have 1 plus and 1 minus. I end up with NaClO3. So that's my sodium chlorate. I'll pick another one. Let's do chromium 3 phosphite, because that's a tougher one. So chromium 3 means it's Cr. The 3 here means I've got a 3 plus charge. Now I've got to figure out phosphite. Okay, so I know that's a polyatomic because it does not end with IDE. And ite means I have 1 less oxygen than the 8. So my phosphate, if I've remembered my phosphate, or if I use Nick the Camel, phosphate is PO4 3 minus. So that means phosphite is 1 less oxygen. So it's PO3 3 minus. Now I check my charges, I do my crisscrossing, and I get CrPO3 oops, sorry, Cr3PO33, but then I have to reduce that down. So it ends up being CrPO3. All right, so now you can sort of start to see how that works. So you name the others, we'll take the rest of them up in class. Let's try another one. Let's try BaCO2. So we'll name this one. So to name it, we literally just name the ion. So I name the positive ion first. Ba is barium. And CO2 is a polyatomic ion. It's not carbon dioxide because it's actually a CO2. So carbon dioxide is just plain CO2. Carbonite is CO2 2 minus, sorry. Okay, so there's a big difference here. CO2 is carbon dioxide, but once you put a charge in, it's not carbon dioxide anymore. So this is not barium carbon dioxide. This is going to be barium carbonite, because CO2 has 1 less oxygen than the carbonate ion CO3 2 minus. Okay, you will notice, I'm not going to go through all of these right now because I don't want this video to be too long, but you will notice that there are some other polyatomic ions that are not on, like not part of, say, Nick the Camel. So I've got acetate, hydroxide, I also have the CN and C2O4. Those are on the orange sheet that I gave you in class, and you are expected to know those ones as well. So again, you do have to do quite a bit of memory work to do this. All right, the next slide has more ionic compounds with polyatomic ions, but I also have the answers. So if you'd like to pause, I believe these are in your notes as well. You have another, I think, 15 or so to do. So I'll put it up so you can see some of them. I'll discuss any of the ones that are trickier, and then that'll be it for today. So here they are. Here are your answers for some more ionic compounds with polyatomic ions. I'm trying to look to see if there's any tougher ones. So ammonium phosphate. That's kind of tricky because it's actually made up of 2 polyatomic ions. And you also have to remember to put in the charges. So here, let's do lead sulfite, lead 2 sulfite. Okay, so how did I get that? You have to know to put those charges, your multivalent charges, which one, you have to know which one goes in that bracket. So how do we do that? So if I've got Pb, SO3, SO3 is the sulfite. If you didn't know that, you should memorize that SO4 2 minus is sulfate. So I know my charge on SO3 was also 2 minus. Okay, and then I just had one less oxygen, so I changed my ending from 8 to 8. So that's where that comes from. But now what's the charge on lead? Well, I have to make sure it's all neutral. So if I have a 2 negative charge on my sulfate, I should have had a 2 positive charge on my lead to balance it out. So that's how I figured out that there was a 2 there, and that's why I put that 2 in Roman numerals and in brackets. All right, if you have any other questions about these, we'll take them up and we'll do lots more practice questions in class. But that's it for your polyatomic ions.